Hello everyone, welcome to my chemistry channel BL Das, short and sweet in chemistry. Now I am going to explain the coordination compound and the topic is terms related to coordination compound. This is the part 4D and where it is for class 12 and according to CBSE syllabus I am going to explain. Now here the terms, that is oxidation number of central atom and homoleptic and heteroleptic. What is mean homoleptic? What is mean heteroleptic? And now it is oxidation number of central metal atom. When you use the word oxidation number, that means whose oxidation number? Central metal atom. What is the central metal atom? That means it is only transition metal. The transition metals only use at the central metal atom. And now oxidation number means when you come to the use of calculation, a difference between the charge of the complex pair. Everywhere you can observe the complex pair, that means coordination pair is there, and above that some number is there, either positive, negative or neutral. That means here what to do, the difference between the charge of the coordination pair minus the total charge of the ligands. You know, ligands either negative ion or molecules or mixture of both. The ligand may be here only negative ion, only molecule, or maybe mixture of both, some negative ion, some molecule. Then what to do? The difference between, suppose it is the central metal is present and ligand is present, then what to do? Here it should be represented by suppose -2. Then what to do here? The total difference between the charge of the coordination sphere. What is the charge of coordination sphere here? -2. Suppose it is a unidentate ligand and charge is -1. -1 if it is 6 times. If it is 6 times, then what happened? That is -6. Again see, difference between the charge of the coordination sphere. This is the coordination sphere and the charge is -2. If the charge is -2 and you will say what is the number of ligands, what is the charge of the ligand, whether it is -1 or molecule neutral 0. Now in this I have explained here, the charge is -1 left. Then what is the number? 6. Then what is the charge of the ligand? -6. Then what is the outer side sphere, that charge? -2. Then you will calculate, that is what is M. M means -2, here -6. Then what is that one? That is here you will get +4. That means if you put +4, see, if you will +4, then automatically it should be -2. Are you clear? What is the oxidation number of central metal atom? That means here you will see difference between the charge of the complex, charge of the coordination sphere minus the what is the charge of the ligand. That you will see what is the number of ligands, what is the charge of ligands. Then you will, after making minus, you will get the charge of the central metal atom, that is called oxidation number. Now oxidation number mean, if you say in mathematics way, charge of the coordination sphere, let it is -2 and charge of the ligand, that is -6. See here, this oxidation number here, oxidation what you will take? M. Oxidation number M. Then what you will get here? The coordination sphere, that is -2. And what is here? Charge of the ligand? -6. Then what is the value? -2. Charge of ligand is -2 and charge of the ligand is minus into minus, that should be plus. Are you clear? This is minus sign and it is minus sign, so plus. Then what is the oxidation number of metal? +6 -2, that is +4. Are you clear? When you will see coordination sphere, what is the value given? You see the charge. Then what is the number of ligands? What is the charge of the ligands? You make a subtraction, that much only. See, represented by Roman numeral. When you see what is the value comes central metal atom, suppose 2, then in parenthesis you will write 2. Suppose 4, in parenthesis you will write 4 in the front of the central metal atom. Suppose copper, if it is 2, then what to write? See here, if copper, then you want to write copper in that is numeral in parenthesis, that is 2. So copper 2. If coordination number, that means here you can't say that it is coordination number. It is only oxidation number. That should be represented by Riemann letter without any charge and in parenthesis. And this value is not equal to coordination number value. How can you get coordination number value? From the ligands. What is the charge of the ligand? How many donor atoms are there? How many donor atoms? Suppose 4. Then coordination 4. How many donor atoms? Suppose 6. Then coordination number 6. That means here oxidation number of central metal atom is totally different from coordination number. Coordination number is a fixed one for a central metal atom. Cobalt, it should be always 6 coordination number. That means 6 ligand donor atom should be there inside the square bracket having charge. Let us see one example. Square bracket starts and Cu Cn whole 4 minus 3. I told Cu what is the charge, you don't know. So write X. Cn is minus 1. So you write 4 Cn minus. Then actually what is the value? You write only value X minus 4 equal to minus 3. Then X equal to what? Plus 1. That means here what is the oxidation number of copper? That is plus 1. But how can you write in a numeral? Which numeral? Roman numeral in parenthesis. That you will write like this. Cu1 in numeral, that is Roman numeral in parenthesis. And coordination number of copper, it is 1 is not coordination number of copper. You see the ligand, it is a unidentate ligand. How many ligands? 4 ligands. These are unidentate ligands. So coordination number of copper is 4 and coordination number has no charge. Oxidation number has charge, but oxidation number is always positive charge. When you express, when you represent, then only you will use Roman letter in parenthesis in front of the central metal atom. Now we will see other example, then I hope it will clear to you oxidation number, coordination number, what is difference between oxidation number and coordination number. How can you calculate oxidation number of a central metal atom? Here you will see the next example, how can you calculate oxidation number of central metal atom. Let us, the example is cobalt and it is surrounded by 2 molecules of ammonia, 4 molecules of chlorine, that is chloride ion. You know ligands, these are called ligands. Ligand mean either negative charge or neutral molecules. Now here it is negative charge, so it is minus 4. It is neutral molecule, charge is 2. So what happens here? This is minus 2 because here minus 4, it is plus 2. So then how can you calculate? Sorry, first you will calculate here. Calculation. How to do calculation? Let us, cobalt is X and ammonia is 0. You know ammonia is a neutral molecule, so 0. And chloride is a anion, the charge is minus 1. So it is 4 Cl minus. That chloride, how many chloride? 4 chloride. So you see here the cobalt is X and it is 0. See, X 2 into 0 minus 4 because chloride is minus 1. So minus 4 equal to minus 2. So what happened? X minus 4 equal to minus 2. So X equal to plus 2. That means when you calculate the oxidation number of cobalt, that is the result is plus 2. Then how can you represent? Representation always by Roman numeral. So cobalt in parenthesis here you will write Roman 2. And here coordination number is totally different. Coordination number, how many ligands? These are unidentate ligand. So 4 plus 2, 6. The coordination number is 6. Are you clear? Again see, how can you calculate oxidation number of cobalt? You should know what is the charge of the ligand. Chloride ion, that is minus 1. Ammonia is 0. You put the value, then comes to X equal to plus 2. Then come to here, this one. Here the square bracket starts Fe, then whole Cn6, bracket close, the charge is minus 4, the question is given. Then what to do? Let here, that is your iron, that is X. You don't know whether it comes to plus 2 or plus 3. If plus 2 then ferrous, if plus 3 then ferric. that is why the iron having X, charge is X. 6 Cn, Cn is a unit-ended ligand, but it is -1 charge. So how many ligand? Cn ligand 6. So -6 and equal to -4. Again see X -6 equal to -4. Then X equal to what is value? +2. And how can you represent? By Roman numeral in parenthesis before, in front of the iron. So this is the oxidation number. How can you represent? And if one question is that answer is +2. If the question is what is the oxidation number of Fe in this compound, in this complex ion, then you should write +2. How can you represent this one? This is the representation. What is the coordination number? You count the what is the number of ligand. It is a unit-ended ligand 6 times. So coordination number is 6. Homoleptic and heteroleptic. Homo means same, similar. Hetero means different. So homoleptic means only one kind of ligand present inside the square bracket and attached to central metal atom or ion. Only one kind of donor group. What is the donor group? That is ligand. The ligand here, if the same kind, just like 6 chloride ion, 6 ammonia molecule, 4 ammonia molecules, if it is represented like this, then it is called homoleptic complex. Then homoleptic means, see again, only one kind of donor atoms, donor groups, and bounded to central metal. So it is called homoleptic. Example you can see here. I put all the charges, cobalt +3. And the charge of the complex +3. What is the charge of complex 3? What is the meaning? That is, it is cationic complex having charge +3. What is the charge of the central metal ion? That is called oxidation number. Oxidation number of cobalt is 3. How many ligands are present? That is 6 ligands. 6, what is that? Ammonia. What is the type of ligand? That is neutral molecule. Are you clear? When you see any complex ion or any coordination complex, then you should remember what are present inside it and outer side it. Let it is here K2 whole square bracket PtCl6. That means here chloride ion, that is the same, only one kind of ion, an ion. So what happened here? This is K2 and it is Pt +4. Pt, what is the charge? +4. What is the oxidation number? +4. What is chloride 6? That what is the value? This is -6. Then you can observe, see, -6 + 4, that is equal to -2. If it is -2, that potassium that having K2PtCl6. The question is here one kind of atoms, one kind of ligands present. That means here chloride the same kind of ligands. That is why it is called homoleptic complex. In that I want to show here it is anionic complex because minus charge is there, having charge -2, and platinum the charge is +4. That means oxidation number of platinum is +4. And what is the anion charge? That is chloride 1 chloride -1, 6 chloride, that is ligand, that should be -6. Then come to other example, Cu the whole bracket, that is Cn4, then over square bracket, and after that there is -3. That means square bracket starts Cu +1 Cn4, Cn4, you should put here Cn4 because it is ligand 4. Now what is indicates? Cn, that is -4, it is -4, and it is +1. The charge is -3. What is the complex charge? What is the charge of this type, this complex? That is -3. What is, how can you satisfy this one? Because copper is +1, cyanide is -1, -1 into 4, -4. So the total charge of the complex anion is -4. And here I want to show only that what is mean homoleptic complex. In 3 complex you can see only same kind of donor groups present, or you can say same kind of ligands present. That is why it is called homoleptic complex. Then you will see what is meant by heterolytic complex. Heteroleptic complex. What is meant by heteroleptic complex? Before that I told what is homoleptic complex. When same kind of ligands present inside the coordination sphere, that is called homoleptic. But what is heteroleptic? Different kind of, more than one kind of donor groups, that is ligand, if present, that is called heteroleptic complex. Now see here, one is ammonia, one type of ligand, and chloride is other type of ligands. That is why it is called heteroleptic complex. Now here I can explain here, it is the oxidation number +3, NH3 whole 4, that is one ligand, but its value 0, chloride 2O, so -2 +3, that is why the complex that having the charge +1, that is called cationic complex. And here chromium is +3, chloride is 2 times, so -2, and oxalate, that group is didentate ligand, so 2 into 2, and oxalate, that is -2 charge, so 2 into -2 is -4, and total it comes to here -3. That means it is anionic complex, and both are called heteroleptic complex because here ammonia, chloride, the two type of ligands present. In this case chloride and oxalato, or that is oxalate ions present, so that is why it is called heteroleptic complex. And how can you name the ligands? Actually it is called oxalato. So here I will explain in the name nomenclature of the coordination compounds. Now I want to go, what are the conclusion of the terms related to coordination compound from 4th A, that is from that 4th A video I have explained all the terms related to coordination compound. Let us start coordination entity. Can I take one example here also? Coordination entity means the ligands and that metal atom or ion, that is area that is bounded to central metal atom, that is called coordination entity. What is coordination entity? The ligands, the number of ligands with central metal atom bounded to central metal atom, and that is called coordination entity. Then central atom or ion, in this case, in both cases you see this is cobalt, this is chromium, and atom or ion now +3, the charge is for cobalt is +3 and charge of chromium is +3, so it is written central atom, central metal, I have here left metal, central atom, not central metal atom or ion. And now here this is cobalt +3, this is chromium +3, these are called central metal ion. Then come to ligands. What is ligand? The group, donor group, the atom donor is present. If one donor atom present, that is called unidentate ligand. Two donor atom present, didentate ligand. If more than two, that is called polydentate ligand. Here see, here the ligand NH3,4 only, this is called unidentate because ammonia can give one donor atom, chloride gives one donor atom, these are called unidentate ligand. And here the chloride is unidentate ligand, and OX, oxalato, is two donor atom, two donor atoms are present, that is why it is didentate ligand. Now next is ambidendant ligand. Ambidendant ligand means that ligand, what are the atoms present? Both atoms can donate, can behave as donor atom groups. That means here suppose Cn, let us here Cn is there, then if Cn is there, carbon also donate electron pair to the ligands, and also nitrogen also donate electron pair to the ligands. If carbon is present, that is carbon donate, that is called cyano group. If nitrogen donate electron pair to the central metal atom, what is called? That is called isocyano, and this is called ambidentate group. Ambidentate group means the ligand, the atoms which both can donate electron pair, they behave as donor atoms, so it is called ambidentate ligand. Then come to coordination number. Coordination number is a fixed one that depends on the number of ligands that act as donor atoms. just like here oxalato, that is a didentate ligand. So here what I want to show, coordination number, that means here chloride is 2 and it is unidentate ligand, this is didentate ligand, it can donate 2 donor atom by the help of 2 donor atoms. So 2 into 2, oxalato didentate ligand, 2 into 2 plus 2, 6. So coordination number 6 for here. For what? For chromium. And how? Oxalato 2 into 2, chloride 2, plus 4 plus 2, 6. Similarly here also ammonia, that is a neutral molecule, and chloride, that is a negative ion, this is unidentate, this is also unidentate, that is why directly 4 plus 2 come to 6, because here since it is unidentate ligand, it can donate 1 pair of electron each. 4 mean here chlorine also, each chloride ion donate 1 pair of electron, 1 donor atom, here also 1 donor atom. So 4 plus 2, 6, that is coordination number. Coordination number 2 times I told. So here then come to coordination polyhedron. Coordination polyhedron mean the ligands which are bounded to central metal atom or ion that are arranged in a what spatial arrangement, that is called spatial arrangement. In space it is arranged, that is why it gives particular shape, geometrical shape, and that is called polyhedron. If 6 coordination number, it should be octahedral. If 4 coordination number, it may be tetrahedral or square planar, which depends on the hybridization of the central metal atom. Oxidation number of central metal atom. Oxidation number, how to calculate? I have already explained. Suppose you don't know this one, if it is X, then what happens? It is 0 value, it is minus 2 value, and here it should be, it is plus 1 already given, then it should be plus 3. So oxidation number of central metal atom, this value will calculate. You know this is 0, this is minus 2, and outer side that complex for plus 1 charge, so you will calculate and comes to plus 3. And then come to homoleptic and heteroleptic. Homoleptic, here homoleptic example is not given here. Anyhow, if one type of unidentate ligand present, or one type any ligand that is same type, same kind of ligand present, that is called homoleptic. But here in this case both are heteroleptic. And here heteroleptic means 2 different kind of, more than 1 kind of donor atoms. The donor atoms should be more than 1 kind of atom. Now see, ammonia, this is one type of ligand, and chloride is other type of ligand, so it is called heteroleptic complex. And I hope it is clear to you. All the terms already I have explained from part 4a video up to here. So I hope you will subscribe my channel BL Das Short and Sweet in Chemistry, and thanks for watching my video. Thanks again to all.